This call is now being recorded.
Yes, I don't want to be late, so we will continue this discussion. Again, an instruction, those who are attending the class by YouTube live and by watching YouTube later, please mark your attendance for the attendance of this class. So either in the live chat അല്ലെങ്കിൽ comment section. So live ആയിട്ട് കാണുന്നവർ live chat ൽ ചെയ്യുക. അല്ലാത്തവർ comment section ൽ നിങ്ങളുടെ attendance mark ചെയ്യുക so that I can put attendance for you. So in the last class, we saw the basic difference between narrowband FM and wideband FM. So narrowband FM, we are making an assumption. That's the basic difference. And wideband FM, we are doing the full analysis. So we write the equation using the Bessel functions. So Bessel functions of will be zeroth order, first order, second order, third order, and nth order. So ideally, n is equal to infinity. So there will be so many components which are coming, like J0, J1, J2, etc. So that is the case. Very much. Okay, we will continue. So in this class, in this session, we will discuss about the FM modulators and FM transmitters. And if time permits, we'll see the FM receivers. So let me share the screen. So we are discussing generation of FM. Generally speaking, there are two methods of FM generation. One is called direct method of FM generation. And the other is indirect method. So direct method direct FM generating. But in indirect method, we are using some other principles. Basically, the principle of that is happening because we found there's a similarity between this narrowband FM and the double sideband AM waveform. So അതുകൊണ്ട് we are trying to generate this FM using AM technique. That's an indirect method of FM generation. We will see that there's one specific method for that. We will see to that. But generally, we have the direct method of FM generation. And what we see is, signal we have to generate the signal. So in general electronics, this is maybe a general thing that I'm telling you. In generally, we can say that we use oscillators. In electronics, there are two types of devices. In analog electronics, one is amplifiers and oscillators. In amplifier, you give a AC signal and the output is also an AC signal. This is an amplifier. But oscillators, what they do is they take DC voltage. In fact, amplifier also require DC voltages. So AC under DC bias ആവശ്യമാണ്, and what they give as output is AC. But in oscillators, you give the DC bias and you are generating the AC waveforms. So these are the two important classification of devices in electronics. One, they will be either amplifiers or oscillators. അപ്പോൾ നമ്മൾ ഇവിടെ ഉപയോഗിക്കുന്നത്, we are going to use oscillators because oscillators generate frequencies. So oscillators are used for generating the frequencies. And there are different types of oscillators. RC oscillators, that is, we use resistors and capacitors. There are LC oscillators, that is, we use inductors and capacitors. Even in fact, we have RLC, where we use resistors, inductors, and capacitors. L represents the inductance. So then we have also, these are basically unstable. Remember, all when we look into these, no, they are with instability undertaken. They are unstable. And in fact, we have crystal oscillators. Crystal oscillators, we use crystals. Symbolically, we draw it like this. Crystals, and they are highly stable. Or the most stable oscillators in the will be the crystal oscillators, and they are highly stable. അപ്പോൾ നമ്മൾ ഉപയോഗിക്കുന്നത്, നമ്മൾ ഇപ്പം മൈക്രോ പ്രോസസ്സേഴ്സിൻ്റെ അകത്ത്, അല്ലെങ്കിൽ നമ്മളിപ്പം ആർഡിനോ അല്ലെങ്കിൽ റാസ്ബെറി പൈ, ഇതിൻ്റെ അകത്തൊക്കെ നമുക്ക് ഓസിലേറ്റേഴ്സ് ആവശ്യമായിട്ട് വരും. അപ്പൊ അവിടെ ഒക്കെ നമ്മൾ ഉപയോഗിക്കുന്ന ഓസിലേറ്റേഴ്സിന്റെ ക്രിസ്റ്റൽ ഓസിലേറ്റർ ആണ്. വി ഡോണ്ട് യൂസ് RC or LC or RLC because hope you have studied, we know, see, every device requires a clock. നിങ്ങൾ ഡിജിറ്റൽ സിസ്റ്റം ഡിസൈൻ അല്ലെങ്കിൽ ലോജിക് സിസ്റ്റം ഡിസൈൻ ഒക്കെ പഠിക്കുന്നതാണ്. അപ്പൊ അതിൻ്റെ അകത്ത് you know there are you would have studied about counters, you would have studied flip-flops. So flip-flops require clocks. So clock signal is very important. So in a counter, in a synchronous counter or in a synchronous counter, we require clock. So when we build these microprocessors, like the processing unit, they require clock because at the clock edges processing നടക്കുന്നത്. Either at the rising edge or at the falling edge. അവിടാണ് പ്രോസസ്സിംഗ് നടക്കുന്നത്. അപ്പൊ എല്ലാം നമ്മുടെ മൈക്രോ കൺട്രോളേഴ്സിന്റെ അകത്ത് എല്ലാം you require clock, and the clock has to be generated, and they are generated using the crystal oscillators because they are very highly stable. But the general or the most lowest level unstable ആയിട്ടുള്ള systems ആണ് RC oscillators and LC oscillators and RLC oscillators. Now, RC oscillator means you can change the resistance value or the capacitance value, and you can bring change in the frequency of oscillation. So frequency of oscillation depends upon you can say the frequency of oscillation depends on, in this circuit it depends on R and C. Here it depends on L value and C value. Here it depends upon the R value, L value, and C value. So in this case, by changing the capacitance value, you can change the frequency of oscillation. In LC circuits, by changing the value of either the inductance or the capacitance, you can change the frequency of oscillation. Changing L is not not usually very easy. So we change the capacity because pala capacitors values capacitors available now. So we change usually the capacitance value, capacitor value. So we change it by changing the value of L and C. അപ്പം നമുക്ക് നമുക്ക് എഫ് എം ജനറേറ്റ് ചെയ്യുമ്പോൾ എഫ് എം സിഗ്നൽ ജനറേറ്റ് ചെയ്യുമ്പോൾ എന്താണ് ഫ്രീക്വൻസി നമുക്ക് ചേഞ്ച് ചെയ്യണം. ഫ്രീക്വൻസി ഇസ് നോട്ട് കോൺസ്റ്റന്റ്, വി ഹാവ് ടു ചേഞ്ച് ദ ഫ്രീക്വൻസി. So to change the frequency, we change the value of these components, constituent components. So FM generation അകത്ത് for FM generation circuit, we use a basic reactance modulator. That is reactance. Hope you remember what is reactance and resistance. Reactance is the value when we say like XL is equal to XL is 2 pi F into L and XC is 1 by 2 pi F into C. Resistance means it is R value. It is based on the resistor. Reactance means it is value of the based on the inductor or the capacitor. The FM generation basically we use basic reactance. Remember the word reactance. That is, we are going to change this values, L value and C value. അങ്ങനെയുള്ള എല്ലും സിയും ചേഞ്ച് ചെയ്യാൻ പറ്റിയാലേ നമുക്ക് ആ ഓസിലേറ്ററിനകത്തെ ഓസിലേഷൻസ് ചേഞ്ച് ചെയ്യാനായിട്ട് പറ്റും. So hope you understood the concept. ഓസിലേറ്ററിനകത്ത് ഫ്രീക്വൻസി ഓസിലേറ്റർ ജനറേറ്റ്സ് ദ ഫ്രീക്വൻസി. അപ്പോൾ ഫ്രീക്വൻസി ജനറേറ്റ് ചെയ്തു. ഇനി നമുക്ക് എഫ് എമ്മിന്റെ അകത്ത് we have to change the frequency. So if you want to change the frequency, we have to change the value of the constituent components. So we have this L and C values. We change the L and C values. By changing the L and C values, we can change the frequency it is generated. So basically, L and C values should change depend upon the message. So എങ്ങനെയാണോ മെസ്സേജ് ചേഞ്ച് ചെയ്യുന്നത് അതനുസരിച്ച് റിയാക്ടൻസ് വാല്യൂ ചേഞ്ച് ചെയ്യണം. ആ റിയാക്ടൻസ് വാല്യൂ ചേഞ്ച് ചെയ്യുമ്പോൾ frequency which is generated will also change. So this has to be brought into ഇതാണ് നമ്മൾ കൊണ്ടുവരുന്നത്. ഈ ഒരു ഐഡിയ ആണ് നമ്മൾ കൊണ്ടുവരുന്നത്. അപ്പം ഇതിന്റെ എഫ് എം ജനറേഷൻ സർക്യൂട്ട്സിന്റെ അകത്ത് ഒരു ഓസിലേറ്റർ കാണും. ആ ഓസിലേറ്ററിന്റെ റിയാക്ടൻസ് നമ്മൾ ചേഞ്ച് ചെയ്യും. റിയാക്ടൻസ് എന്ന് വെച്ചാൽ ആ കമ്പോണൻസ് which generate this oscillations and we are changing the reactance part. അവിടെ നമ്മൾ സിലബസിൽ we have to specifically we are asked to study specifically about varactor diode modulator. So we will go directly to varactor diode modulator. So remember ഇത് പഠിക്കുമ്പോൾ we have to learn at the circuit level. അപ്പോൾ ചെറിയൊരു സർക്യൂട്ട് കമ്പോണന്റ് ആണ് ഉള്ളത്. We will study that circuit. We have a capacitor. This is an inductor basically. This is a diode, varactor diode. It's a special type of diode. So this is the varactor diode. We have capacitance here. The ground is will be coupled with the transfer. ഇവിടാണ് നമ്മൾ ഓഡിയോ ഇൻ കൊടുക്കുന്നത്. This is actually an RFC. And this is capacitance, coupling capacitance. This is the varactor diode. And this is the biasing capacitance. So RFC is a radio frequency choke. Choke is an inductor, and radio frequency means it is used in radio frequency. Above audio frequencies means low frequency. Radio frequency means higher frequencies in the range of kilohertz and megahertz. Audio frequencies 3 to 3 kilohertz ആണ്. 3 hertz to 3 kilohertz, 2 hertz to 2 kilohertz ആണ് നമ്മൾ audio എന്ന് പറയുന്നത്. But radio frequency means higher than that, more than 2, like 100 kilohertz. 2 megahertz range. അവിടുത്തെയാണ് നമ്മൾ റേഡിയോ ഫ്രീക്വൻസി എന്ന് പറയുന്നത്. സോ റേഡിയോ ഫ്രീക്വൻസിക്ക് ഉപയോഗിക്കുന്ന ചോക്ക് ഒരു ഇൻഡക്ടർ സർക്യൂട്ട്. ഇൻഡക്ടർ എന്ന് പറയുന്ന വേറൊരു വാക്കാണ്. കോയിൽ നമ്മൾ പറയുന്നത് ചോക്ക് എന്ന് പറയുന്നത്. സോ ഇൻ RFC is called. So C is the capacitance. We have CC and CB, they are capacitance. Capacitors. And P is our varactor diode. So what happens is, depending upon varactor diode bias അനുസരിച്ച്, depending upon the bias, the capacitance value will change. So അതുകൊണ്ടാണ് അതിന്റെ സിമ്പിളിൽ തന്നെ ഒരു ഡയോഡ് ഉണ്ട്. If you look at the symbol, we can see that it has a diode. Diode is another. Then we have a capacitance also. Symbol of the capacitance, because its capacitance value changes according to the bias. There's a change in the capacitance. So this property is being used in our varactor diode modulator. So depending upon whatever is the audio signal that is coming in, this is a coupling transformer. So that audio frequency changes to be coupled. Audio signal will be coupled to this circuit, and this circuit forms the tank circuit, like a resonating circuit. So ഇതിന്റെ ബേസിസിൽ ആയിരിക്കും നമ്മുടെ ഇത് ചേഞ്ച് ചെയ്യും. എന്തായിരിക്കും നമ്മുടെ റിയാക്ടൻസ് ചേഞ്ച് ചെയ്യുന്നത്. ആ റിയാക്ടൻസ് ചേഞ്ച് ചെയ്യുന്നത് now this is a part of the oscillator. ആ ഓസിലേറ്റർ ഞാൻ വരയ്ക്കുന്നില്ല. Okay, so this is a part of the oscillator, and when the bias voltage changes, so audio voltage വരുന്ന അനുസരിച്ച്, so depending upon this audio voltage, the bias here changes. So when the bias changes, its capacitance value changes. So here it forms a L and C, inductor and the capacitance combined ചെയ്തിട്ട് capacitance. അപ്പോൾ ആ reactance value change ചെയ്യും. ആ reactance value change ചെയ്യുന്ന അനുസരിച്ച് നമ്മുടെ frequency of oscillation change ചെയ്യും. So that is what it happens. I hope it is clear. That is, depending upon the audio signals, we find that the biasing changes, and as the bias changes, we find that the reactance. I think, in fact, I can say that the capacitance of varactor diode changes, and when this changes, the reactance changes, and when reactance changes, the frequency of oscillations. So make it into segments. So depending upon the audio signal, the bias changes, which results in the change in the capacitance of the across the varactor diode, And varactor diode is part of the RFC or the chalk, radio frequency chalk, and this together combines as an LC circuit. So the C value is changing, so the resonating frequency changes. So as the resonating frequency changes, or the frequency of this, or I can say the reactance changes. So depending upon the reactance, this is part of an oscillator circuit. So the frequency of oscillation will change. So you can generate an FM signal. This is what happens at the varactor diode modulator. Uh, this is how FM is generated. So FM generation using the varactor diode. And this is a modulator. This is just a part of it, and this forms the transmitter that the correct components of that. There will be amplifier and the power amplifiers, and then you will have antenna. In between you have the modulator, and then you have the antenna, power amplifiers, and antennas through which the signal is being transmitted. ഇനി ഇതിൻ്റെ അകത്ത് ഒന്ന് രണ്ട് കൺസേൺസ് ഉള്ളത്, see, if you are going to directly generate the FM signal, it will be highly unstable. So it is highly unstable because this direct method is because we are using LC circuits. And LC circuits, no, or LC tank circuits, they are inherently very unstable. നമ്മളിപ്പോൾ ലാൻഡ് ചെയ്യുമ്പോൾ പോലും നമ്മുടെ എൽ സി സർക്യൂട്ട് ഉണ്ടൊക്കെ ഔട്ട്പുട്ട് കിട്ടാനായിട്ട് വളരെ പ്രയാസമാണ്. അത് വളരെ ഷാർപ്പായിട്ട് ഒരു പർട്ടിക്കുലർ പോയിന്റിലായിരിക്കും അതിന്റെ ഫ്രീക്വൻസി ജനറേറ്റ് ചെയ്യുന്നത്. ട്യൂണിങ് ഈസ് വെരി ഇമ്പോർട്ടൻറ്റ്. ട്യൂണിങ് മീൻസ് ഹൗ യു ചേഞ്ച് ദ എൽ ആൻഡ് സി വാല്യൂസ്. സോ അത് വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. അപ്പോൾ ഇങ്ങനെ നമ്മൾ ജനറേറ്റ് ചെയ്യുന്നത് ഹൈലി ഒരു അൺസ്റ്റേബിൾ ആയിട്ടുള്ള ഇതാണ്. അതുകൊണ്ട് ചിലപ്പോൾ നമ്മൾ ചെയ്യുന്ന എന്താണെന്ന് വെച്ചാൽ വി ക്രിയേറ്റ് എ നാരോ ബാൻഡ് and then we go for sorry what we do is we generate the FM at a lower frequency and then we multiply it. We use frequency multiplication. So we use frequency multiplication and generate a wideband FM. So we use FM oscillators, and then what we do is we use frequency multipliers. And we use frequency mixers. So mixers means you have to use local oscillators. So multiplication means you are multiplying it by n times. But frequency mixing means you are going to add a particular frequency. Let me tell it like this. Multiplier means, see, if phi is equal to fc plus delta, then after multiplication you get n times is equal to n times fc plus n times delta. So we can see the frequency deviation also will be multiplied. Mixing means Fi is equal to Fc plus delta F. So when you are going to change, it is FC will be changed to some other value. Maybe this part will not change. Frequency deviation will not change. But normally we are using FM oscillators. That is what we discussed. Something like varactor diodes we can use. But now we are generating at a lower frequency. We are going to multiply the frequency. So the frequency will be multiplied n times. So the carrier frequency will be multiplied and the frequency deviation also will be multiplied. We are doing that because നമുക്ക് direct ആയിട്ട് large frequency deviation generate ചെയ്യാനായിട്ട് ബുദ്ധിമുട്ട്. It is highly unstable. So അതുകൊണ്ട് we are going for the next techniques, that is the indirect methods. Of FM generation. And that is one important method is very, very important, Armstrong's method. Armstrong is the one who found this method, so that is why we use Armstrong. We gave the name Armstrong. So this is an indirect method of FM generation. Indirect method of FM generation. So we are not going to use oscillators here because that technique is really unstable. But what we are going to use? Okay. Let me see 1 minute. Oscillators നമ്മൾ ഉപയോഗിക്കും, but we have so Armstrong method, it is actually based on the our equation, previous equation that we wrote. S of t is equal to AC cos 2 pi fct then we have minus beta into AC sin 2 pi fct into sin 2 pi f1 into t. So we are going to use this equation. I am going to draw it like this. Let me try to draw. We have our message. Remember, our message is cos 2 pi f1 into t. So to get sin 2 pi f1 into t, you have to integrate it. So we have an integrator. And after this integrator, you have a product modulator. It is, we have to do a multiplication. That is what we are writing, a product modulator. So one input to the product modulator is our signal. And what is the second me review. This is a 90-degree phase shift. And we are going to generate the carrier. This is generated using a crystal oscillator, because crystal oscillator is very stable. So it generates the crystal oscillator generates the carrier. Is given a 90-degree phase shift. So crystal oscillator signal 90-degree phase shift sign aki. Then we take the product of the crystal oscillator, phase shifted crystal oscillator and sine 2 pi fmt. Sine 2 pi fmt is our message. Then what we do? Then we have to do with this process. AC cos 2 pi fct minus beta into AC. So it is actually giving a mixer. So mixer the run inputs on that. This component is phase shifted component. So this will be subtracted. Remember here it is minus. So here we will write it minus. Here we will write it plus. So this is mixer. So these two are mixed together. Then what we do? Then we go for the frequency multiplier. Depending upon the need, you can do that. You can do down conversion using a local oscillator or a crystal oscillator. And then you give for the second. You give for the amplifiers. So it is a it is given out of the input. Maybe I will explain it one more time. So it is based on our equation. It is based on our equation because our narrow band FM signal is AC cos 2 pi FCT minus beta AC sine 2 pi FCT into sine 2 pi FM into T. This is exactly. We are taking the product of this multiplication. So ഇവിടെ നമുക്ക് carrier generate ചെയ്യണം, ഇവിടെ message generate ചെയ്യണം. So what we have as the block diagram is we use a crystal oscillator. So it generates FC. And this is given to a mixer. Here we have cos 2 pi FCT, here we have sine 2 pi FCT. So to get sine 2 pi FCT, I have to do 90-degree phase shift. So ഇവിടെ ആരോ ഇങ്ങോട്ടാണ്, ഇവിടെ ആരോ ഈ 90 ഡിഗ്രി ഫേസ് ഷിഫ്റ്റ് ചെയ്ത് തന്നെ മൾട്ടിപ്ലൈ ചെയ്യണം. സോ ഐ യൂസ് എ product modulator. So product modulator, product എടുക്കുന്ന എന്തൊക്കെയാണ്? ഒന്ന് sin 2pi fct, ഒന്ന് sin 2pi fmt. So ഇവിടെ എനിക്ക് sin 2pi fmt കിട്ടണം. sin 2pi fmt എന്ന് പറയുന്നത് you are integrating the message. So message signal integrate ചെയ്യുന്നു. Integrate ചെയ്യുമ്പോൾ sin 2pi fct കിട്ടി. അതിന്റെ പ്രോഡക്റ്റ് എടുക്കുന്നു. പ്രോഡക്റ്റ് എടുത്തതിന് ശേഷം it is given to the mixer. മിക്സറിൽ ഈ കമ്പോണന്റ് നെഗറ്റീവ് ആണ്, ഈ കമ്പോണന്റ് പോസിറ്റീവ് ആണ്. So that it will do this component minus this component. So mixing is done. After mixing is done, you are going to do frequency multiplication. So multiplying it by n times. So what you will get is NFC plus n times delta FM. Frequency multiply ചെയ്യുന്നു. അതിനുശേഷം we are doing down conversion. So down conversion ചെയ്യുമ്പോൾ we need to give another crystal oscillator. So slow state direction ഇങ്ങോട്ടാണ്, down conversion direction ഇങ്ങോട്ടാണ്. So down convert ചെയ്ത് കഴിയുമ്പോൾ നമുക്ക് കിട്ടുന്നത് FC plus n times delta. So we'll change such a way. So ഇവിടെ നമുക്ക് n minus 1 times FC. n minus 1 times FC. ഇവിടെ നമുക്ക് പ്ലസ്, ഇവിടെ നമുക്ക് മൈനസ് ആയി. കാരണം NFC നിന്ന് n minus 1 FC times കുറയ്ക്കുന്നു. Or already done it is down conversion. So no need to put this in down. So you get here FC plus n delta, and this is amplified and then given to the antenna. Antenna is a omnidirectional. So this is the Armstrong method of FM generation. So this is a very important technique because we don't directly generate the FM. We use the technique of narrowband FM and generate the FM signal. So this is our method of FM generation. Either you can use varactor diode modulator and then directly generate the FM, or use this kind of Armstrong method and indirectly generate the FM signal. Okay, next class we will look into the FM demodulators, how to demodulate the FM signal. So today's class we look into the two types of FM, this wideband FM and narrowband FM, and then we saw the circuits for varactor diode modulator and the block diagram for Armstrong method of indirect generation of FM signal. So we will meet tomorrow. I hope most of you will join tomorrow also for our class. We'll have a time of discussion. Okay, thank you. Thank you, Hasna, for joining.
Thank you, sir.
Yes. Okay. Bye-bye. I will be sharing this notes in the class, Google Classroom. So you can collect it from there. So all those who have not put the attendance, please put the attendance in the live chat or in the comment section.